Today, discuss one important part of mathematics, which is after Riemann integration, after improper integral. Also, going to this portion. This portion is important and also taught in MS standard in Indian universities. Also taught in Banaras Hindu University, one of the famous central university of India. Also taught this course when I'm in a MSc student standard. So I now just start this topic. This topic is measure theory. Okay. First I discuss something about here. Right, we know about that Riemann integration a to b f dx. If be bounded, then f is Riemann integral. We know about that if ab to r be defined and also bounded. Okay, if f bounded, then this one is f integral. That means integrability concentration is bounded. Okay, if then obviously here Riemann still is also that means for further discussion about f d alpha. Okay, then obviously this one is ab upon this f of d alpha. Okay, in this way we also discuss Riemann still obviously here alpha is that means some monotone functions or bounded functions. And now we're going to generalization of this and obviously talk about measure theory. Okay, here we define some spaces. These spaces are we are say this L1 space. Small L1 space is a sequence space summation mod of x n less than infinity n equal to 1 to infinity. Okay, L2 space, LP space, we know about that summation n equal to 1 to infinity norm of x n whole to the power p whole to the power 1 by p less than plus infinity. Okay, in this way we also discuss this one, but now we also considered, that means we're going to measure theory step by step to discussion about that some integral function which is not bounded. When then in that type what we discuss about that. So we need help of measure theory. We start about the definition of algebra. Okay, algebra and sigma algebra. Now let X be a non-empty set. Let X be a non-empty set. Okay. Then A be a collection. A be a script. A be a collection of subsets of X. Collection of subsets of X. Then script A is said to be. Then script A is said to be an algebra if first condition is x belongs to script A and phi belongs to whole x, that means whole set x is belongs to script A and phi belongs to script A. Next, if a1 a2 an if a1 a2 an belongs to the script A, then union of I equal to 1 to n ai belongs to script A. Okay, then this script A is called algebra. Okay, when we call the collection be algebra, even x and phi whole set and null set is belongs to the script A, that means this collection. And a1 a2 an in collection sets, then finite union of these sets is belongs to this collection. Okay, then we call it this collection be an algebra. Now we're going to discussion about sigma algebra. When we talk about sigma algebra, let X be a non-empty set. Okay, non-empty set, and same thing, and script A be a collection of subsets of A, subsets of X. Okay, then script A is said to be an or a sigma algebra. Okay, a sigma algebra if first one X belongs to the script A and 5 belongs to the script A, and second one if A belongs to oh not here we also give one, that means this one we also forget. If A belongs to the script A, then A complement belongs to the script A. Okay, and here obviously this one also we write. Okay, that means second condition this, if A belongs to script A, then A complement belongs to the script A. Okay, and again we erase this portion, then we write third condition. Our third condition is so and simply we write here in this way, if A1 A2 AN dot 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 be in script A, then union of I equal to 1 to infinity AI belongs to this script A. That means countable collection of these sets belongs to this script A. Okay, if algebra, then finite union of these sets is belongs to this algebra, and here in sigma algebra we write just countable collection of union, and others are same, X and 5 belongs to the script A, that means collection. And here if A belongs to script A, then A complement belongs to script A. So we write this definition of algebra and sigma algebra. When we called a collection an algebra, if X belongs to this collection and 5 belongs to this collection, and if A belongs to this collection and A complement belongs to this collection, if finite number of sets belongs to this collection, then union of finite number of sets belongs to this collection, then we call this collection be algebra. And X be a non-empty set and this script A be a collection of subsets of X, then A is said to be a sigma algebra when X belongs to the script A, 5 belongs to script A. If A belongs to script A, then A complement belongs to script A, and if A1 A2 AN dot 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 countable number of sets belongs to this script A, then union of this countable number of sets are equal to 1 to infinity AI belong to script A, then we called it sigma algebra. Next we talk about every sigma algebra is an algebra. Okay, we are obviously going to this definition we known about it. Every sigma algebra is an algebra, but we now let write here. Okay, from this observation what we get every sigma algebra is an algebra. Okay, next we talk about let X be a set and A equal to collection of phi X, smallest sigma algebra on X. X non-empty set and A equal to phi X, the smallest sigma algebra, the collection of phi X be the smallest sigma algebra, okay, on X. Next we talk about here X be a set not equal to phi set, then A equal to px, that means all subsets of X. Okay, this collection contain all subsets of X, then be the largest sigma algebra. Okay, now Now we're going to discussion about one. Let A be a subset of X. Then we also denoted this script A equal to phi A complement X. Then what happened? What happened? This one is the smallest sigma algebra. This one is the smallest sigma algebra containing A. Okay, containing A. If A contain, then no smaller sigma algebra other than this. Okay, so again we start about that. Here we talk about let X equal to this real number set and A equal to closed interval 0 1. Then what we talk about this collection equal to phi and A complement. Okay, then this one is the smallest sigma algebra. What this one is right in this way: phi A equal to closed 0 1 and B equal to A complement means here minus infinity, here minus infinity to 0 union 1 2 plus infinity. Okay, this collection of sets is called and sigma algebra containing this closed interval 0 1 and this is the smallest sigma algebra. Okay, now we talk about another example where it is this portion and going to another example of this. Okay, now we write it in proposition way. Then this one is beta. We write here proposition. Okay, that means let X equal to a real number set and let this collection script A equal to S belongs to this R, a subset of this R. Okay, a subset of this R, not belongs to, a subset of this R such that A or A complement is countable. A or A complement is countable. Okay, then this collection is an algebra. We have to prove that this collection be an algebra. Okay, how we prove it? We prove it by satisfying those conditions which is stated in this definition. So how we write this one? Also prove, yeah, this one, first one, right here, note X complement equal to phi. Okay, X complement equal to phi equal to R complement, then R belongs to this script A, because this one is phi is countable, and obviously here we write if R belongs to this A, and then obviously phi belongs to this A. Okay, why? Because either A is complement or A complement is complement, then phi belongs to A. If phi complement or phi complement phi is must be complement, so phi is here and R is here. Okay, now second is let A belongs to the script A, then by definition that means what type of this collection is either A complement and A complement is complement, so a countable or either A countable or A complement is countable. That means here by definition A or A complement is countable. Okay, then we write it in this way: A complement or A complement whole complement equal to A is countable. Yes or no? Yes, not a problem at all. We write in this way. So we talk about here this one, A complement belongs to this, what, this collection. So we talk about here if A belongs to this complement, then we get A complement belongs to this collection. So second conditions are satisfied. Now we're going to third condition. We write here let A1 A2 AN, let A1 A2 dot AN belong to this script A for some n belongs to natural number set. Okay, then suppose that what we talk about now, this one a1 a2 dot 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 an are countable. We just let this one, if this one is countable, otherwise this one countable or these complements are countable, but we suppose this one is countable. Then what happened? Then then obviously union of I equal to 1 to n ai is countable, because finite collection of countable sets is countable. So this one is done. Okay, then what happened? Then we talk about that hence union of I equal to 1 to n ai belongs to this script here. Okay, now we're going to this conclusion. It is the above portion which are also be finished. Now we're going to another topic. Suppose that now we suppose that what a1 a2 an are a1 a2 dot 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 an are not countable. Then what happened? Okay, not countable, then what happened? Then there exists at least I0 belongs to 1 to dot 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 n such that ai0 be uncountable. Okay, be uncountable. If they all are not countable, then this one is uncountable. Then what happened? Then we know about here this complement, this is not uncountable. Then a complement equal to I equal to 1 to n ai complement. This equal to what? Intersection of I equal to 1 to n ai complement by De Morgan's. Okay, you use De Morgan's here. Then this one obviously ai0 complement, obviously ai0 be uncountable. Then here talk about ai0 complement be countable by this, since ai0 belongs to this collection. Okay, so either ai0 is countable or ai0 complement is countable. So happen here ai0 complement is countable, because we talk about that ai0 be uncountable. So this implies that a complement be countable. Okay, then what happen? If a is uncountable, then a complement is countable. So therefore we talk about that union of I equal to 1 to n ai belong to this script A. Okay, since a is script A, this implies a belongs to this. Okay, because a equal to this, we let this one. So what happened? Therefore we write here a b and algebra. Okay, this one I think easy part. We are checking algebra or not, too easy part, so we do it in this way. Next we also erase that portion and going to another proposition. Okay, now we're going to another proposition. This proposition we construct here. Okay, let x not equal to 5 be a set, be a sequence. Here we also not construct set on finite, this one, this, that means finite collection will not construct. Here we construct one sequence, x equal to a and b a sequence. Then this script a equal to a subset of this sequence where a or a complement is finite. Okay, then we have to prove that a is an algebra. Okay, So how we prove this one? How we prove this one? First we write a1. We check about it. Note that x complement equal to 5 and belongs to this script A. Okay, because x equal to a and x complement obviously finite, phi is finite. Okay, now we also talk about that here phi belongs to a and x belongs to a. Okay, x belongs to a since x complement belongs to this a. Now to a2, why? Let a belongs to this collection script A. Then by definition what? A or a complement is finite. Okay, this implies that a complement or a complement whole complement is finite, since a complement whole complement equal to a. This implies that a complement belongs to this script A. Next, 3a3, how we discuss about that? Let a1 a2 dot an belong to this collection script A, and then here we write for some n belongs to natural number, and then a1 a2 dot an are finite, or a or ai this complement not needed here. We also let this one is finite. Okay, let us suppose that this one not finite. Then what happened? Then we know about that union of I equal to 1 to n ai belong to this script A, because union of I equal to 1 to n ai are finite, because finite union of finite sets are finite. Okay, then we talk about same thing in this way. We erase our portion and going to talk about in this way. If suppose that they are not finite, suppose that a1 a2 dot an are not finite, so what happened? What there exists I0 belongs to 1 to dot n such that ai0 be not finite. Then ai0 complement be finite. So what happened? Then we known about that union of I equal to 1 to n ai complement equal to intersection of I equal to 1 to n ai complement subset of ai0 complement. Okay, then this one is finite, so we write here union of I equal to 1 to n ai complement is finite. So this one is finite. This implies that union of I equal to 1 to n ai belong to the script A. So this implies that script A be an algebra. I understand. Now we are also going to another observation. We erase this proposition now and going to another observation about that. Okay. Right here observation, here we talk about define a1 equal to sequence a1, not here a2, and if a2 equal to this one a4, that means 4 8 in this way I think, and here an equal to dot an equal to here a2n. Okay, In this way, one sequence is defined. Then what happened? Then I think note that an belongs to note that an belongs to this script A. Okay, for n belongs to this natural number set. So an is a sequence in script A. Further, we write here, further, union of n equal to 1 to infinity a of 2n. This sequence equal to a to a4 dot 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 a to n dot dot dot. Okay. In this way, this one is an infinite set. This one is an infinite set. But what happened? Union of n equal to 1 to infinity a to n. Complement is okay. This one obviously one infinite set. Therefore, here what happened? Here we check about that A is an algebra. Okay, that means if we construct finite collection, then this was it done. But if we call an infinite collection, then these two are infinite set. Okay, here this one is finite. If we construct a complement, then infinite. But if we construct in this way, that means union does not belongs to this script A. Okay, so therefore we write here, therefore this collection be an algebra but not sigma algebra. Be an algebra but not sigma algebra. Okay, so we're now going to one example for which this collection is satisfies, that means is an sigma algebra but not sigma algebra hold. That means we also going to one observation that every sigma algebra is an algebra but every algebra is not sigma algebra. So we find here one example. Okay, this example shows that that means this example shows that what this script A be an sigma, not an sigma algebra, not a sigma algebra but an algebra. Okay, so today we also going to discuss of just definition of algebra, sigma algebra. That means we known about set of collection, and this collection are various types. We talk about two types, algebra and sigma algebra. Certain properties are held in this collection. Then this one is called algebra and sigma algebra. Some differences here. If in algebra just finite addition, finite union belong, and in sigma algebra countable union belong. Okay, we also discuss some example, also some propositions here discuss. So today we also stop here. Okay.